around the same time, late 1800s, early 1900s, as Joseph John Thomson, Robert Millikan was doing his oil drop experiment. So essentially the setup was very similar. We had two charged plates, a positively charged plate and a negatively charged plate. And in the center, very carefully and tediously, was suspended a charged blob of clock oil. Millikan used clock oil for no other reason than it was commercially available in a pure form. But clock oil is neutral, and you can't manipulate something neutral between two charged plates. So to enable the manipulation of this object, he blasted clock oil with X-rays. X-rays are considered ionizing radiation, so as the X-ray comes in, it blasts off electrons, or cathode rays, and those electrons then spray other molecules of clock oil. The ones that pick up the electrons can be manipulated by an electric field. So this sphere in the center represents one blob of clock oil. The negative charges represent however arbitrary number of electrons it picked up. And by adjusting the electric and magnetic fields, similar to the way Thomson was able to, Millikan was able to suspend the clock oil between the plates. To suspend the clock oil between the plates, the force down and the force up must be equivalent. The force down is because of Newton's law. So F equals mg. Newton said that F equals ma, but here acceleration is gravitational acceleration. So F equals mg. And the force up, let's say, is the electric force, so it's the charge on the electron multiplied by the electric field. So when the oil droplet was suspended, and Millikan was able to know it was suspended because he could look through his machine through a look glass, then we know that the force due to gravitation was counterbalanced by the force due to the electric field. If we now solve for E, so E, or the charge on the electron, is the mass of the electron divided by the gravitational potential, or the acceleration due to gravity on this planet, over the electric field. So Millikan was able to contribute the charge of the electron. And he was able to calculate it to be approximately 1.6 by 10 to the negative 19 coulombs. So let's summarize Thomson and Millikan together. So Thomson and Millikan, how were they able to, or how were their contributions summative? Thomson was able to give us the charge to mass ratio, or the mass to charge ratio. Any way you look at it, it was a ratio. Millikan was able to give us the charge, or if you like, the inverse charge, whichever way you look at it. So together, they could establish the mass of the electron. So together, they contributed the charge to mass ratio, the charge, and the mass of the electron. So I recommend you study Thomson and Millikan together. In the next video, we'll look at Ernest Rutherford's contribution to atomic theory and his discovery of the nucleus.